The engine of Excel is its formulas. Formulas are what make up the foundational framework of Excel, and they are where the power of the application lies. Below the ribbon, we have what is called the formula bar. This is where all the formula magic happens. Everything calculation-wise in Excel, except for the formatting and a few other logistical processes, is completed via a formula. Formulas work on a cell-by-cell basis and are one-for-one, meaning that you can copy a formula to a new cell, but a cell itself can only have one self-contained formula. A formula can have multiple parts in a string, however, but that's still one formula per cell. One very important thing to note is that all formulas, when entered into a cell, must start with an equal sign. This lets Excel know that a formula is about to be calculated. Without an equal sign, Excel just thinks that you entered a string of values or text, and it can't do anything mathematically with that information. At the end of the day, Excel is basically a giant calculator, and it needs a starting point for each calculation, and the equal sign does just that. So this is what the formula bar looks like. It's a long, slender white space above the column headers and just below the ribbon. Let's take a look at a formula example. Here I have entered a simple addition formula that adds together two cells, A1 and B1, and as you can see, the formula bar displays that simple addition formula. Notice the equal sign in front of the formula, which tells Excel to do the calculation between those two cells, A1 and B1. So that's the basic structure of a simple formula in Excel, which we will now build from. Often in an analysis, you will need to lock certain cells, rows, or columns so that you can copy formulas correctly. Locking means that either the column or row reference within a cell is fixed or locked, so that when you copy that formula to a new cell, it will always retain the reference point of that column or row in the new cell. Locking cells, or relative references as they are also known, is a powerful way to save time and ensure accuracy when you're doing an analysis. The way you lock rows or columns in a formula is by using the $ symbol. Let's look at a cell reference. Here we have cell C1. The cell is currently unlocked or normal at this point. By adding a $ to the left of the column reference, C, and to the left of the row reference, 1, the cell is now locked. Each $ locks either the column or the row, and in this case, when they come together, locks the cell itself. So what that means is that in Excel, you can lock the column and row, or either of them individually. If we start with the fully locked cell C1, and remove the row reference $, only the column, in this case, column C, is now locked. And if we remove the column reference $, the row 1 is now locked and the column is unlocked. So this is all well and good, but it's a bit abstract here. Let's do an exercise and see what this looks like in practice. Now that you've been introduced to formulas, let's learn how to use a few of them. We will cover each formula at a high level and then move into Excel for a hands-on exercise. The blue text highlighted in each formula that we will cover is the main portion or start of that formula that performs the actual calculation in Excel. Let's first start with your basic math operations like add, multiply, subtract, and divide. These are relatively straightforward in Excel and use the usual operators such as the plus sign, the minus sign, the multiplication symbol, as well as the division symbol. Next we have sum. The sum has the same mathematical outcome as the addition formula, but it is useful when you're adding together a row or column that is made up of multiple cells. We'll see this in action soon. The third formula on our list is average. It's used extensively in analyses. As you would expect, this brings back the average of a cell, a row, or even a column. The next two formulas, min and max, are just like they sound. They find the minimum or maximum of an array or range. This is useful if you're looking to determine the minimum or maximum value in a large data set. Count is also useful for finding the number of items in a row or column. Again, this is also practical when you have a large data set and you would like to know the number of items that make up that data set. Next, date takes the individual cells and turns them into a combined date using year, month, and day of those specific reference cells. So for example, if you have one cell that has 2007, another that has the month of 12, and another that has the day of 31, you can use the date formula to combine the 12, 31, and 2007 into December 31st, 2007. The end of month formula is a derivative of a date, but it takes the date and provides the end of the month date. So for example, if you've got May 12th, 2007, as an example here, this will convert that May 12th into May 31st, 2007. It's good for bucketing and filtering and that sort of thing. It can also be used to provide previous or subsequent months. So you can change the formula from a 0 and you can change it to a 1, and that'll bring the next subsequent month. We'll look at that in a little bit more detail here in a second. Next we have year, which simply brings back the year of a specific date. So for example, if a date is May 10th, 2017, then this formula will bring back the year of 2017. Pretty simple. And lastly, we have value, which converts text to a number. This can be very useful in cleaning up data prior to an analysis. So for example, you may have data in a cell that looks like a number, but in fact it's not. The value formula, if that data is actually a number, will convert it into a useful numerical format. So let's add some clarity to this by doing an exercise with these formulas in Excel. Alright, so for these exercises, we're going to be working in the basic formulas before workbook. So what we have here is we have just monthly sales data. So very straightforward for 2016. So we have from January through December and then the monthly sales numbers. So on the right hand side here, I have the basic formulas that I would like you to do. So the first one we're going to do is the basic math equations here. So in order to start a formula, we remember from the previous lesson that every single formula in Excel has to start with an equal sign. So that is what I'm going to do. I'm going to input equals. So that is letting Excel know that there's a formula coming. So just to show you the addition, let's make this simple. I'm going to go to cell C9. I'm going to add cell C10 to it using the plus sign. So I just hit the plus sign and let me hit enter, and you're going to see that those two cells now are added together using the plus sign. So for addition in Excel, we are going to use the plus sign. Now, going along that same train of thought, we can also do subtraction. So again, starting with the equal sign, I'm going to now subtract C9 from C10, and I'm going to end up with a negative number here because February has more sales than January. So there we go. You can see that negative 28,200. Now I can do the same thing for multiplication, and again I'm going to start with an equal sign, and I'm going to multiply the C9 times C10 using the star symbol. So that is multiplication in Excel, which is the star. So I'm going to click enter, and obviously that is a very large number, so let me expand this so you can see that. 57,257,000, okay? So the last one here of the basic mathematical equations we're going to do is division. So I can do equals to, and I can do the same C9 divided by C10, and I'm going to get a division here, and that is 0.88. You can also convert this to a percentage if you wanted to see what the January sales were as a percentage of February sales. So those are just your basic divisional and well as subtraction and multiplication and other different basic mathematical formulas in Excel. Now, sum is very similar to addition, but we can do it on a range or a multiple set of cells. So I'm going to start my formula again using the equal sign, as every single formula in Excel needs to start with an equal sign, and I'm going to type in the words or the word sum. Okay, you'll see that it prompts me with a drop down there, and it gives me the option for sum when it gives me a description. It says adds all the numbers in a range of cells. Perfect. So I'm going to hit tab in order to select that, and I'm going to come over here to my data set, and I'm going to select cell C9, and I'm going to hold down the shift key, and I'm going to hit the down arrow key to select cell C10 as well. Now I'm going to click enter, and you'll notice that this sum is also equal to the same number as the addition. So it's just another way of doing this. Now, where this becomes useful is I can do this across this entire year of data. So let me change that. I'm going to do equals again to start the formula, type in sum, hit tab to select that formula, and navigate over to the sales data. Hold down shift, hit control, and hit the down arrow key, and I've selected this entire range now. I can click enter, and this is now my total sales for 2016, and I've used the sum formula in Excel to get this number. So it's a little bit easier than coming in here and just doing, if I do equals, I could do this plus this plus this and so forth. You can see that that took probably 3 or 4 times as long as just doing sum equals to that other information here. So it's just a quicker way of adding together all of the values in a range. I can do the same thing and find the minimum number of this sales data by also doing this on that same range of C9 through C20. So I'm going to do equals to, and I'm looking to type in MIN, and that's going to give me min, which returns the smallest number in a set of values. It ignores logical values in text, which makes sense because we're looking for a minimum number in this case. I'm going to hit tab, I'm going to come over to my range, shift control down arrow key, select my range and hit enter. And I can see my minimum value here is 225,600. And let's just go and peruse this data set. And it looks like eyeballing, yep, January looks like the lowest number here. Okay, now next, I can also get the average of this data set. The way I can do that again is start the formula with equals and then look for average. And here it is. It returns the average or arithmetic mean of its arguments, which can be numbers, names, arrays, references that contain numbers. Interesting. You can do this for other things other than numbers. We'll get into that later, but for the purpose of this, let's focus on the numbers here. I'm going to hit tab, come over to our range, shift control down arrow key, select that, and then click enter. So I can see here that my average is 256,517. So how can I check that? Well, I can select this range and I can come down here to the bottom and Excel summarize this for me. 256,517. I can also check my sum function here, 3,078,200, 3,078,200. So we're on the right track. Perfect. So the opposite of min is obviously maximum, or max. So I can do the same thing, type in max, hit tab, and it tells me that it returns the largest value in a set of values, ignores logical values in text, just like min did. So let's do that, navigate over here, highlight our sales data or select our sales data, hit enter, and there's my max number, 267,200, 267,200, looks like November. Perfect. Okay, great. So we're well on our way here with the min, average, and max formulas. So what happens if I wanted to know how many months are represented in this data? Now it looks pretty obvious here. We have January through December, so 12 months. But what happens if I had a bunch of more data? I'd like to verify that. So the way I can do that in Excel is to count the number of items using the count formula. So I'm going to do equal sign again and type in count, and I'm going to use the first function here, the first formula that says count. It counts the number of cells in a range that contain numbers. So in this case, I want to know how many of the months have sales. So I'm going to hit tab, I'm going to come over to my range, I'm going to highlight it, control shift down arrow key, and hit enter, and I should get 12, and I do. Fantastic. So what happens if I wanted to count the months? Well, I can also do that using the count, because in this case these months are numerical values, and I also get 12. But say here that I had a text number here that said January, and this was 2016. Okay, so Excel is going to convert that into a number. You can see that it did 1/1/2016. Well, let's force it to do text. So the way you do that is you do this delimiter at the top here, and you type in January. So now this is text. If I do that same count, Excel is not going to recognize that. It's going to say 0 instead of 1. It doesn't know what to do with it. So the way to avoid that is to do a count A, or let me back up a little bit. It counts the number of cells in a range that are not empty. So hence the text. It's going to count that text now. So if I go back and I choose that same value in A9, I should get 1, and I do. So there's a lesson there. You can use count for numerical values, which in this case, dates in this format here, in B9 through B20 are in numerical format. And I can show you that by hitting this comma symbol here. You'll see that Excel actually formats dates like this. We change them to the date format just to show you and make it easier to read and also understand. So if it's in text format like this, Excel's not going to be able to count it. So we need to use a count A function in order to do that. Okay, so moving on and keeping with the date theme, there is a formula in Excel called date. So say I have a few numbers here. I have a month, a year, and a day. So I want to get these into one specific date format that I can then use. So what I do is I do equals to start my formula. I type in date, and it returns the number that represents the date in Microsoft Excel using the date timecode. Okay, let me hit tab. So my year in this case is 2017, so I'm going to select my year. I'm going to do a comma as it prompts me there. You can see that comma there just to the right of year. I'm going to hit month, which is 12, and then I'm going to hit day, which is 20. So logically, what I'm thinking that this is going to return is 12/20/2017 in a date format similar to this in column B. Let's see what it does. Okay, great. It does exactly what we wanted to do. So let's take this one step further and say we just wanted to pull out the year for this data. So let me do that and type in year. And this returns a year of a date in an integer range from 1900 to 9999. Okay, so we're not going to run out of years in Excel. So let's hit tab, highlight this cell in I11 and click enter, and I got 2017, exactly what I wanted. So what's the application for this? Well, let's say you had this sales data here, and I'm just going to add a column here, and I want to add a year just for example. Okay, what I can do is use the year function here, or the year formula, and click on that 2016, and I just need to format this correctly, so I can just do general formatting, and I can double click on this little item here, this highlighted box here, the square, and I can double click on that square, and what Excel is going to do, it's going to automatically fill this formula all the way down. Okay, so it did 2016 all the way down in this range in D9 through D20. So now I have the year for each of these months represented in column B. So what's that useful for? Well, say I had a very large data set and I had years ranging going back 10 years or something like that. Well, in Excel, I could use this formula to come up with the year, and then I can use that year as a filter or a bucket in a pivot table. So that just makes things easier to analyze data. It's also clean up your data and also put it in a way that's easier to analyze in general. So that's some of the basic formulas that you're going to use in Excel. We're going to expand on these later on, but this is sort of the foundational formulas. There's a whole bunch more in Excel, but you're going to need to know these in order to become a good analyst. In the introduction to this lesson, we learned that locking cells or ranges can be valuable when using formulas. It also helps retain the integrity of the mathematics and formulas within your data analysis. So let's look at a practical application of what locking cells or ranges looks like in Excel. All right, so what I've got here is that same sales data we looked at in the basic formulas tab in this workbook. But we've been tasked by our CEO to project the estimated sales for years 2017 through 2020 using these growth rates. So the way that our CEO would like us to do this is, instead of taking the annual sales, they would like us to take the average sales for the last 12 months in 2016, which is this 256,517, and then apply the growth rate, which is here in column F, to that monthly average and then multiply it by 12. Okay, seems easy enough, but how are we going to do that? Well, let's do a couple of housekeeping things first. Let's set up how many months we need first. So if you recall, we can use the count function in Excel to do that, or the count formula in Excel to do that. So let's type in a metric here, number of months. Okay. Let's do the count. So let's do that. And let's click enter. And there's our number of months, which is 12. Perfect. All right. So let's come up here and estimate the sales. So if you recall, we need to do the average monthly sales for 2016, add a growth rate on top of that, and then do the multiplication by 12 to get an annual number. Okay, so let's do the first step there. So let's enter an equal sign. Let's go down to our average sales for 2016, which is this average here in cell C22. Let's apply a growth rate to that. So we need to do a multiplication times 1 plus this number right here, which is the 5%. And then we can multiply that by our number of months here in cell C24. Okay, so you can see I've got a bunch of cell references in my formula here. I've got C22, which represents the average sales for 2016. I've added a growth rate here using the estimated growth over the sales of 2016 by 5%, and then I've multiplied that by the number of months, which is 12. Now I need to do one correction here. My math teachers would be upset with me if I did not do an order of operations here correctly, so I just need to add parentheses around the first set to tell Excel to calculate that first, then multiply it by the 12 months. Okay, I'm going to hit enter. Okay, great. So let's just plug in our actual sales here for 2016 so we can see that this is working correctly. Okay, perfect. So let me see, if I do this divided by that, I should get the 5%. And I do. So the growth rate is 1.05, which is 5% over the previous year. So that works out well. Now, if you recall, in the previous lesson, I showed you how to drag down a formula using this little highlighted square here. So what I can do is just double click this and scroll down. But that didn't work. Why? Well, that's where locking cells comes into play. This doesn't come up with any value that makes sense because we did not lock the certain cells that are the inputs for this formula. So I'm going to click F2 just to see what's happening here. Okay, so it looks like our growth rate, or F11, is working correctly. our C23, what's that? Well, it looks like it moved one cell down. And the same thing for C25, it moved one cell down. I wonder why. Well, that's where locking comes into play. I did not lock the average sales per month, and I did not lock the number of months in a year. So I need to fix that before I can drag or double click the formula down. So let's go ahead and go back up to cell G10 here. I'm going to click F2, and what I need to do is lock this blue highlighted cell and this purple highlighted cell. And the way I'm going to do that is to click on the cell between the cell reference of the column, which is C, and the row reference, which is 22, and I'm going to click, or I'm going to hit F4 on my keyboard. F4. You'll see what that does is it places dollar signs here, puts one in common, the column reference and in front of the row reference. So this cell now, this average, is locked. I'm going to leave the growth rate F10 as it is, and I'm going to lock the number of months as well as C24, and the way I'm going to do that is click F4. So now that cell is locked as well. So I've locked my average sales and I've locked my number of months. I'm going to hit enter and watch what happens. And this time I'm going to copy the formula down a little bit differently. I'm going to hit Control C, I'm going to shift down arrow key, and what I'm going to do now is I'm going to hit Control V for paste. Much better. We have a much more realistic number here. Alright, so there's one more topic I want to cover before we wrap up this lesson, and that's concatenation. So concatenation is just a fancy way of saying combination or combining two things, two values. So the way that this is done in Excel is through a formula. But let me give an example of a concatenated item first. So I'm going to type in my last name here, and I'm going to add a comma, and then I'm going to type in my first name. So this is a concatenated value. I have my last name over here, separated by the comma delimiter, and then my first name here. So this effectively combines two things. It combines my last name and my first name with a comma. So let's come over here in cell D9 and do this in Excel using a formula. So I'm going to start with my equal sign, and I'm going to type in concat, and you'll notice two options here. One is just the new version of the formula in Excel, which is the first one. They've shortened it to concat, and then the second one here is concatenate. So either way, we should be fine and get the same outcome whichever formula you use. Yours may just look a little bit differently depending on your version of Excel. So I'm going to hit Tab, and the first thing I'm going to do is select the last name because that's what we want first. So B9 here is the last name that I want to bring in. Next, I'm going to do a comma to start a new text value, and first I have to do a open quotation mark. So why do I have to do quotations? Well, I want to add a comma, so I'm going to hit the comma key, and that is going to bring in a comma, which is going to be our delimiter. But in order to let Excel know that, I need to put it in parentheses to signify it being text. So I'm going to hit a space here, and you'll see why in a second, and I'm going to add the close parentheses, and then I'm going to add another comma here. So this effectively, this portion of the formula here is our delimiter. So that is what's going to separate our two values. Next, I'm going to click on the last name cell here, which is C9, and I'm going to click Enter. Interesting. Cool. So that basically separated our first and last names and combined them into one column. So I can come over here and you can see it's very similar to what we had in the example here. I'm going to double click on this little square here, copy down the formula, and I see it's working correctly. Great. So that's how you concatenate two values using a delimiter that are residing in two separate columns. Well, there's a little bit of an easier way to do this rather than to have that concatenation formula. So I'm going to delete this, and I'm going to do the exact same thing, but instead of using the concatenation formula here, I'm going to use the and symbol or ampersand. So I'm going to do equals again. I'm going to come to B9, and here's the difference. I'm going to hold down the Shift key and then look for the and symbol, just like that. So the same logic applies here. I'm combining something using the and symbol rather than the concatenate formula. I'm also going to do an open quotes here, the comma, space, and then the close quotes, then another comma to separate the values, and then I have to do and then I have to bring in the B or C9, excuse me, in this case. Now, what's going to happen here is we should get the same output as what we had before with the concatenation formula. This is just a little bit of a quicker way to do it. So let me click enter, and it's going to give me a quick warning error here, and I want to click yes, and what it's going to do is give me the same output here. So basically what I've just done here is done a quicker way to concatenate things without using the concatenate formula. I did that by using the and symbol, and we get the exact same outcome, which I can now copy down to these cells using the and symbol instead of the concatenation formula. So just a little bit of a different way to get the same output at the end of the day. All right, so let's recap this lesson. What did we learn? So we learned that the ribbon is where the majority of the functionality in Excel lives. And we learned that Excel works on a column and row structure. We also learned that formulas are the engine within Excel, and that all formulas need to start with an equal sign. We also learned how to use a few basic yet powerful formulas in Excel that you'll likely use on a daily basis as an analyst.